Proxima Centauri, the closest star to our solar system, has had astronomers hooked for years. Back in 1915, a Scottish astronomer named Robert Innes spotted this small, red star. It's part of the Alpha Centauri star group, along with Alpha Centauri A and B. Even though it's only about 4.24 light-years away, which is pretty close in space terms, you can't see it without a telescope because it's not very bright. But don't let its dimness fool you. Proxima Centauri is a goldmine for scientists, mainly because it has a planet called Proxima b. This exoplanet orbits right in the star's habitable zone. Red dwarfs like Proxima are smaller and cooler than our Sun, and they live much longer. They're not very bright, so it's hard to see them. The spot where the temperature is right for liquid water is closer to the star. For Proxima Centauri, that spot is only 0.05 astronomical units away, way closer than Earth is to our Sun. Because it's so close, Proxima b gets blasted with a lot of star activity, like solar flares and high radiation. It's a very different place than Earth. Finding Proxima b was a big deal for folks searching for exoplanets. Using a technique where they look for tiny wobbles in Proxima Centauri's movements caused by the gravity of a planet, they figured out the planet's size and orbit. In 2016, the European Southern Observatory said Proxima b was real. It was a huge step forward in the search for planets that might have life. Here's the thing. Most of what we know about Proxima b is from guesses. Telescopes on Earth have problems with the atmosphere and light, so it's hard to get good info about the planet's surface or air. To learn more about Proxima b, we need better tools, like the James Webb Space Telescope, JWST. Proxima Centauri is super important for learning about planets outside our solar system. Since it's the closest star system to Earth, it's a great chance to study what makes a planet livable. Proxima b is interesting because it's about the same size as Earth, rocky, and might have water. But it's also a tough place to live. That's where the James Webb Space Telescope comes in. It's a big step up from the Hubble telescope. While Hubble looks at visible and ultraviolet light, JWST mostly uses infrared light. This lets it see through space dust and spot things Hubble can't. One of JWST's best parts is its huge 6.5-meter mirror. It's made of 18 pieces covered in gold, which makes it better at seeing infrared light. It can gather way more light, so JWST can see really faint and far away stuff. It also has a sun shield to keep its instruments cold, about -233 degrees Celsius, which is needed to detect faint infrared signals. JWST hangs out at the L2 point, about 1.5 million kilometers from Earth. This keeps it away from Earth's heat and light so it can watch the universe all the time. JWST's infrared skills mean it can check out objects whose light stretches as the universe gets bigger. It can help answer questions like how galaxies started, how stars are born, and what makes a planet good for life. Its instruments, like the near-infrared camera NIRCam and the mid-infrared instrument MIRI, make it like a time machine and lab all in one. Proxima b has grabbed the attention of scientists and regular folks. Since it's in its star's habitable zone, it might have liquid water. It's about 1.17 times the size of Earth and likely rocky, like our planet. Being just over 4 light-years away, it's a good place to look for life beyond our solar system. But Proxima b isn't a twin of Earth. It's tidally locked, meaning one side always faces the star, while the other is always dark. This makes the temperatures super different on each side. The line where day meets night might have temperatures that could support life. Still, life on Proxima b would have problems. Proxima Centauri sends out a lot of solar flares, which are bursts of X-rays and ultraviolet radiation that could strip away the planet's atmosphere. If Proxima b has air, it would need a strong magnetic field to protect it. Without that, life would have a hard time on the surface. On Earth, some organisms can survive high radiation by fixing their DNA. Maybe life on Proxima b could have similar tricks. It's also possible that Proxima b's tidally locked thing could help. While one side gets cooked by radiation, the dark side could be a safe spot. Caves or oceans under the surface could shield life from radiation, like how life lives near deep-sea vents on Earth. It's a natural lab to study how life could survive in tough places, and it offers a good chance to explore how adaptable life can be. As we get new telescopes and space missions, Proxima b will continue to be a focus in the search for life beyond Earth. If there's alien life out there, this might be the first place we find it. Proxima Centauri's nature as a red dwarf poses some challenges. It's smaller, cooler, and dimmer than our Sun, meaning its habitable zone is really close, about 20 times closer than Earth is to the Sun. This means Proxima b is constantly hit by high-energy solar flares, which are sudden and release dangerous radiation. These flares are stronger and happen more often than what our Sun does. Without a magnetic field, Proxima b's atmosphere would be at risk, slowly getting stripped away and leaving the surface open to radiation. Even if there's some atmosphere left, the high radiation makes it hard for life to start or survive. Ultraviolet radiation breaks down complex molecules needed for life, which is a big problem. Even so, some Earth creatures have found ways to handle radiation damage, suggesting that life on Proxima b might do the same. Because the planet's tidally locked, the dark side could be a safe place, with caves or oceans offering protection. These spots might allow microbes or extremophiles, organisms that like living in extreme conditions, to survive. Scientists see Proxima b as a way to study how life could make it in tough settings. Its location and environment make it great for ongoing study. There will be new telescopes, and someday we might figure out if life exists there. The search for life beyond Earth will take a while. As tech gets better and our knowledge of space grows, planets like Proxima b are key parts of the puzzle. It reminds us that life might find a way even in the toughest spots. The story of Proxima b is just getting started, and with more study, we might finally learn secrets of life beyond our planet. There are many interesting things about it, and it has complex challenges, so it remains a key part of this space search. Each new thing we learn about this world helps us better get what things are needed to support life. As folks make better instruments and missions, Proxima b is a prime spot, maybe redefining how we understand our place in space. The ongoing study shows the spirit to finding out and the human drive to learn all the secrets of the stars and getting us closer to find out if we are alone. As we zoom in on it, we are getting closer to seeing if it could have any form of life, even if it is small bugs chilling under ice or in caves away from the sun flares. Scientists are like space detectives piecing together clues from light years away, hoping to crack the case of life beyond Earth. If it is a rock, the lesson we learn will help up in the search for other planets with even better tech. All in all, Proxima Centauri and its planet are more than dots in the night sky. It is a big adventure to find out the unknowing. Now imagine some people interstellar gardeners on that planet to find life seeds. They want to know how that planet can nurture life seeds. They are studying form star that can zap them and the setup it has that has a day and night setup. Like a house that halfway is roasting and half freezing. Not the vacation spot, but hey, life find a way on Earth. Like Earth has its force field. Scientists well if Proxima b might because it will game changer in the long run. It is stuck in a day and night showdown. So the way to look as it is a puzzle warped in a mystery sprinkle with is. It helps use to see how it can exist and push use to thing beyond the look. The hunt for life is not another planet. Plus, it has a special sun shield that keeps the instruments super cold, about -233 degrees Celsius, which is essential for spotting faint infrared light without getting interference from its own heat. Unlike Hubble, which orbits Earth, JWST chills out at the L2 point, a stable spot about 1.5 million kilometers away from Earth. This keeps it away from Earth's heat and light, letting it watch the universe non-stop. JWST's infrared skills mean it can study things that are redshifted, whose light stretches to longer wavelengths as the universe expands. It can answer big questions like how galaxies formed, how stars are born, and what conditions might support life on other planets. Its instruments, the near-infrared camera NIRCam, mid-infrared instrument MIRI, and near-infrared spectrograph NIRSpec, make it kind of a time machine, lab, and sign of human smarts all in one. Proxima b has grabbed the spotlight with scientists and the public. Sat comfortably in its star's habitable zone, it might have the right stuff for liquid water. It's about 1.17 times Earth's mass and likely rocky, similar to our planet. Being just over 4 light-years away, it's the perfect spot to study life beyond our solar system. But Proxima b isn't Earth's twin. It's tightly locked, meaning one side always faces its star in daylight, while the other side is always in darkness. This makes for big temperature differences between the two halves. The small strip where day meets night, the Terminator line, might have okay conditions that could support life. Life on Proxima b faces some hard realities though. Proxima Centauri is a flare-happy red dwarf, constantly shooting out bursts of X-rays and ultraviolet radiation that could strip the planet's atmosphere over time, exposing its surface to harsh space stuff. If Proxima b still has an atmosphere, it probably needs a strong magnetic field to protect it. Without this shield, life as we know it would have a tough time surviving on the surface. On Earth, some organisms, like Deinococcus radiodurans, can survive high radiation by fixing their DNA. Maybe life on Proxima b, if it exists, could have come up with similar tricks or even new ways to do things. What is interesting, Proxima b's tidally locked nature might give it some protection. While one side roasts in constant radiation, the dark side could be a safe place. Underground caves or oceans beneath the surface might shield life from radiation, similar to how life thrives around deep-sea hydrothermal vents on Earth. Despite all the rough conditions, scientists are still hoping that Proxima b may be a second Earth. At the same time, that planet gives a good chance to study how life handled the challenge to live there. Studying how life might survive there could also help us begin to get how a plant can really be called livable. In the big space quest, Proxima b isn't just one place where we may find a home. It is also a place where we can test how to live. With how close it is to planet Earth and its location, it is one of the best bet we can have today. Proxima Centauri's nature as a red dwarf star brings unique challenges. It's smaller, cooler, and far less bright than our Sun, which means its habitable zone is snugly close. The closeness of it to Proxima b means it faces constant attacks by those flares we talked about. These flares are more intense and frequent than our Sun's, posing a real possible threat. If they are strong enough, this will damage the place we wish to research there. Without a protecting field made by the planet atmosphere, the place we want to research will hurt some things and eventually damage everything. Ultraviolet rays can lead to complex things breaking down in the body. However, some creatures on Earth can handle that radiation. That means somehow life can adapt to the surrounding they are in. The planet is locked on to Proxima Centauri, which can allow for protection from the radiation because of the planet not moving. Scientists view it as a test rather as a place to move. We can all learn something from it. New telescopes are constantly going to get built. It's not a question of if but when. It reminds us that even in the worst of situations, life can be found. Each new fact that is uncovered leads to a new path. This helps us understand where planets can evolve and what type of situation is needed.